Hey, this is a small video of line integrals, like what they are, what do we get from them, and how to evaluate them in Matlab. This is the definition of line integrals. Like you have a function in 3D and you have a curve. So if you slice that function along that curve, you get a surface area. So that is what you get from line integrals. Let's see what it looks like. So here you have a 3D sphere, that is your function, and you have a curve on this plane. So if you slice the sphere along that curve, so this is your area and this is what you get from line integrals. So there's a small code how to evaluate line integrals in Matlab. So first thing is you define the variables that are x, y, and z, and second thing is you input the curve. Then you have to input your 3D function, and the last thing that you have to input is the values of your x's. Basically, we are gonna simplify each and everything in terms of x. So after that you have to find dy by dx, that is this, and similarly you have to find ds by taking a square root to this quantity. So that is what I have done here. So and then you find the integrand, that is f into dx. F is a function and ds is your curve. Then you integrate finally the whole thing with respect to x. So let's take this example. Here your function is x into 1 plus 4y and your curve is y is equal to x square. First you have to enter your curve in terms of x, and second thing is your function. Your function here is x into 1 plus 4 into y, and enter your x input. So here we have the lower limit of x as 0 and higher limit as 1. So you can see your final answer is 2.7451, and that is what you get from this code. So in line integrals we have a different kind of format for 3D, which is given by F.dr bar. A typical example of this is work done, where you have work done is equal to line integral f bar dot ds bar, where f bar is your force field and where we have fx, fz, which are the respective components of f bar, and similarly we have dx, dy, dz, which are respectively the components of ds bar. So if we can integrate this line integral, we get a component of the vector field which is intersected by this curve. So let's get back to Matlab. So here is a small code to validate this also. The code is simple and similar to the previous one, where you have to first enter your curve in terms of x, and then you have to enter your function. So here you will have to enter function in terms of x, y, and z format. So basically you are gonna enter the function in the form of vector, and similarly you have to input the x also in the vector format, and this is your integrand, and you are gonna integrate everything with respect to x here. So basically we are simplifying each and everything, that is y and z, in terms of x. So let's run this code. So what we get here is, so let's take an example here where your vector field is 2xy I bar minus 5x j bar, and dr bar is dx plus dy. So we have to enter, first thing is curve in terms of x. The curve here is y is equal to x cube, so let's enter y is equal to x cube. And second thing is you enter your function. So your function was 2 into x into y I bar, and minus 5x in the j direction. So here we have to enter both the function in the form of vector and enter your x input. X was going from 0 to 1. So your final answer is minus 67 by 20, and you can check it here. this is your solution, and your final answer is minus 67 by 20, and that is what you have got from this code. So thanks for watching.